Today we're going to talk about how to solve systems of equations by graphing. Now, systems, when we hear that word, all that means is that we have more than one equation. So in our case, we have two. You could have three, four. You could have as many as you want. But in our case, we're going to just deal with two for systems of equations. Now, notice how we are already in y equals mx plus b form. We're in slope-intercept form, meaning that y is by itself, or y is isolated, and everything else is on the other side. Our x term is first, showing us what our slope is, and our number by itself, our constant, is going to show us our y-intercept, or our starting point. What we're trying to do is we're trying to figure out where, when I graph these two lines, are they going to cross? At what point do they cross? And that will be the solution to our answer. Meaning that when I would go and plug back in the coordinate point for x and y, it should be true for both equations. Now, my starting point for number one, this top line, we have a positive 3, so I'm going to start up 3 right here. That is my starting point. And then the direction I'm going to go is I'm going to go down, because of the negative, down 1, right 3. So down 1, right 3, down 1, right 3. Now, again, what if you ran out of room? The opposite direction you could go is up 1, left 3, up 1, left 3, up 1, left 3. And notice how it still falls in that line. Let's go ahead and draw our line as best we can. And that goes on forever. I don't need to think that just stops at those points. Kind of missed the line here, but that goes on forever in both directions. Now, what about our second line? Sometimes people want to label this as, hey, this was line 1. This was my top line that I drew. And hey, now I'm going to go ahead and graph line 2 onto the coordinate plane. Line 2 starts at -4. That is my starting place. So from 0, 0, I'm going to go down 4. And on the y-axis, that's why it's called the y-intercept, I'm going to plot my first point at -4. Then my direction says, hey, go down 8, right 3. But notice I can't go down 8. I'd be off the paper or off the coordinate plane that I have. So because I can't go down 8 without adding more lines, the opposite direction of going down 8, right 3, somewhere over here, would be to go up 8, left 3. So let's do that and see if it fits. So from here, we're going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And then left 3. 1, 2, 3. Notice how they share the same coordinate point. Something like this would be better to have a straight edge as you connect these, but connect them the best as you can. And our solution is going to be right here at that coordinate point. So the x comma y, or our coordinate point here, is left 1, 2, 3, and up 1, 2, 3, 4. That means this coordinate point is the point -3, comma 4. Meaning if I were to plug in for every value of x, -3, and for each value of y, +4, I would get them to be equal to each other. This is the only point between both lines where the solutions are going to be equal. Now moving on to number 2. Number 2 is a little different because we don't have it solved. So we have to solve this and get it into y equals mx plus b form first before we can actually go ahead and graph on the coordinate plane. So let's take a look at this one. This first one, I want to get y by itself, or isolate the y variable. So I need to move everything not attached to y over to the other side. So the first step, if you want to draw your wall, is to subtract 8. So after I subtract 8 from both sides, notice that I have 2y equals, I have a 5x and a -8. Those are not like terms, so I cannot combine those together. One has a variable, one does not. I want to write it in order of slope-intercept form. So I want my variable term to come first. So I'm going to write my 5x term first and then the -8 after it. Then finally I'm going to divide by 2, but notice I can't just divide 2 from one term. I have to divide 2 from every term on both sides of the equal sign. So the 2y is being divided by 2, the 5x is being divided by 2, and the -8 is being divided by 2. What that gives me is y by itself equals, let's write this as a fraction, so 5 over 2x. Normally we don't like fractions, we think, but actually with graphing, fractions help us because this is our slope. Here's my rise, and here's my run. Now -8 divided by 2 is a -4, so we're going to say -4. So this is going to be the first line that I'm going to graph on this coordinate plane. My starting point is -4, so I'm going to go ahead and go down 4 on the y-axis, 1, 2, 3, 4, and I'm going to put a point here as my starting point. From there, I'm going to go up 5 because it's positive, and then to the right 2. So from this point, I'm going to go up 5, right 2. Up 5, 1, 2, 3, 4, 5, right 2. And again, 3 points is good enough. Instead of going up 5, right 2, if you wanted to, you could go down 5, 1, 2, 3, 4, 5, and then left 2. And what you see is that this still makes a straight line. So we're going to connect those as best we can. Now, this was the first line that we graphed. Let's go ahead and take a look at line 2. So here's equation 2. And let's get y by itself here. Notice how all three terms, y, x, and b, are on the left side of the equal sign. So we have to move the other two terms over before dividing by the 2 attached to y. It doesn't matter the order. Let's just put it in order of mx plus b. So let's move our x first. So this is a positive 1x. So how I get rid of this is by subtracting that x for both sides. So those cancel out. I'm left with 2y minus 4 equals a negative x. From here, 2y minus 4, I want to get rid of that minus 4. So the opposite will be to add 4. And again, those are not like terms. So I have 2y equals, I'm going to write my x term first. So that's a negative x. And then that's a positive 4, so plus 4. Finally, to get y by itself, I'm going to divide all terms, every term, by 2. So I get that y equals, that is technically a negative 1x. So we're going to write that as a fraction, negative 1 over 2x. I want you to get used to writing it like this. Plus 4 divided by 2 is 2, so that's a positive 2. So this is line 2 that I'm going to graph. So y equals m, negative 1 over 2, x plus b, our starting point is 2. So on the y-axis, I'm going to place a point here at 2. My direction I'm going to go is I'm going to go down 1, right 2. Notice how the very first time I go down 1, right 2, I see where these points intersect. And that's all I'm looking for. In line 2, I'm looking for where it's going to cross or intersect with line 1. Don't forget your final, this isn't your answer, just showing your work on the coordinate plane. Your answer is that coordinate point where they intersect. So let's go ahead and find that. So x comma y, so I'm going to go right 2, up 1. So my x comma y, the coordinate point is 2 comma 1. And remember, x comma y. This is actually my solution to this systems, or to the two equations that we have. If I were to replace in the first and second equation x with the number 2 and y with the number 1, I would see that they would equal to each other, and that's the only coordinate point that is true for both equations.